Hey guys, in this lesson we will talk about special triangles and its applications. Special triangles is one of the requirements of trigonometric functions. We have two basic things to understand before doing trigonometric functions. One is special triangles and one is called unit circle. Unit circle will be covered up in the next lesson. This lesson is dedicated to special triangles. Now the purpose of special triangles is to help determine the trigonometric ratios without using calculators. So the specific angles for which we are able to find out the trig ratios are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Two special triangles have been created that incorporate these angles, so 3 in each triangle. Both the triangles are right triangles. The first triangle is 30-60 triangle because it's the right triangle, so one of the angles is definitely going to be 90 degrees. And second triangle is 45-45 triangle. This being a right triangle, this is also 90-degree angle. The trig ratios that we are going to deal with is primary trig ratios, that is sine, cos, tan. Always remember with the trig ratios will come the angle that we are calculating the ratio for. And there are reciprocal ratios as well. Reciprocal of sine is cosecant, reciprocal of cos is secant theta, and reciprocal of tan is cot theta. No matter if it's primary or if it's reciprocal trigonometric ratios, trig ratios always come with angles specified with it. Now it is assumed that the students remember from previous grades SOHCAHTOA, where O means opposite, H means hypotenuse, and A means adjacent. To understand SOHCAHTOA, it means that sine of an angle, because we do not know the angle right now, so just the general term for the angle is theta. Sine theta is equal to opposite over hypotenuse. This is the ratio for sine. To get cosine or cos theta, we need to do adjacent over hypotenuse, and to get tan theta, we need to do opposite over adjacent. Similarly, if we want to get the reciprocal ratios, so cosecant theta will be equal to, just reciprocate it, hypotenuse over opposite. Secant theta will be equal to hypotenuse over adjacent, and cot theta is equal to adjacent over opposite. Now, how are these special triangles useful to get all these trigonometric ratios? So now we have 6 trigonometric ratios to work with. Let's redraw the triangles. Let's say we have the triangles and we are supposed to find out sine of 30 degrees because the angle is now specified. So we write down the angle instead of writing theta. If we want to find out what is sine of 30, we know SOHCAHTOA means sine is opposite over hypotenuse. So sine 30 is opposite over hypotenuse. We look at 30-degree angle, and opposite over hypotenuse means these are the side lengths. So opposite side length divided by hypotenuse side length. That's what we are looking for. Now, when we say that we have to memorize special triangles, that means we just do not have to memorize the angles. We also have to memorize the side lengths. Side length for 30, 60, 90 triangle is 1, square root 3 and 2. Side length for 45, 45, 90 triangle is 1, 1 and root 2. This side is the hypotenuse length. Hypotenuse side is always the side that's opposite to 90-degree angle. So this side is hypotenuse. Hypotenuse never changes because angle 90 degrees is the one that is deciding what is the hypotenuse going to be. Now let's say we're working on 30 degree. So this is 30 degrees. For 30-degree angle, let's write it with red color. For 30-degree angle, the opposite side is this, and the hypotenuse never changes. So this is the hypotenuse. So if we have to write on the ratio of sine 30, that would be 1, because this is the opposite side, over hypotenuse value is 2. So we write down 1 over 2. You see here, if you want to know what is the value of sine 30, we do not need to use our calculator. All we have to do is just read it from the special triangles. If we want to find out what is cos 30, then again, for 30-degree angle, we know cos is adjacent over hypotenuse. Adjacent is going to be this side. Side on which the angle is lying is called the adjacent side. Now, why don't we consider this side as adjacent? Because this side is already given a term called hypotenuse, and that cannot be changed. So this is the adjacent side for 30-degree angle. So cosine 30 is adjacent over hypotenuse. That is equal to root 3 over 2. Similarly, if you want to find out what is tan 30, that would be opposite over adjacent. That's TOA. So opposite is 1, adjacent is root 3. We get 1 over root 3. If we want to find out what is secant theta, we know secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, secant will be hypotenuse over adjacent. Therefore, secant theta is going to be hypotenuse over adjacent. So 2 over root 3. And similarly, we can find out the rest of the ratios. Now let's work with 60-degree angle. Let's say we're asked to find out what is sine 60 degrees. So let's mark this as 60 degree. For 60-degree angle, opposite is this side because this is the opposite side. And 60 degrees lying on this. So this side is going to be adjacent for 60-degree angle. Hypotenuse definition is not going to change because 90-degree angle still stays there. So sine 60 is opposite over hypotenuse. Opposite value is root 3. Hypotenuse is 2. So we would write down root 3 over 2. Similarly, if we have to find out cosine 60, we know cosine is adjacent over hypotenuse. So cosine 60 is 1 over 2. And in the same way, we will find out the tangent value, secant value, cosecant value, cot value. All we need to worry about is defining opposite, adjacent, and hypotenuse sides on the triangle. If that is done correctly, the ratios can be figured out correctly. Let's see how to work on the 45-45 triangle. The method stays the same here. We notice here this is 90-degree angle. So opposite to 90 degree is hypotenuse. We would define our hypotenuse first. If we are asked to find out what is sine 45, then we are not looking at this triangle, then we are looking at the 45-45 triangle. So if this is 45 degree, because both are 45 degrees, doesn't matter which 45 degrees you want to take. So 45 degrees, opposite side is this, adjacent side is this. So sine 45 is opposite over hypotenuse. Opposite is 1, hypotenuse is root 2. We would get 1 over root 2. If we're asked to find out tan 45, we know tan is opposite over adjacent. So 45 degrees opposite is 1, adjacent is also 1. So it's 1 over 1, which is 1. If we're asked to find out cosecant 45 degrees, we know cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant will be hypotenuse over opposite. So for 45-degree angle, hypotenuse is root 2. And opposite is, if you're taking this angle, this becomes opposite. If you're taking this angle, this becomes opposite. It does not matter because both sides are same, so opposite is 1. Therefore, cosecant 45 is root 2. And this is how we use the triangles to get these ratios. Let's say now we're given the ratio. However, we are asked to find out the theta value. So basically, we're looking for angle. Theta means we're looking for the angle. If the ratio is containing the numbers root 3, 2, or 1, that means it comes from the special triangles. So we can use the special triangles to find out the angle. We do not again have to use the calculator. We know sine theta is opposite over hypotenuse. Now we know root 3 is contained in the first triangle, so we do not have to look at the second triangle. What we would see is where is the opposite root 3. So for which angle? The opposite is root 3. If we consider 30-degree angle, opposite is 1. If we consider 60-degree angle, opposite is root 3. And we are looking for root 3 as the opposite. Hypotenuse stays the same too, so we do not have to worry about hypotenuse. From here we get to know that when theta is equal to 60 degrees, then the opposite is root 3. Therefore, we can conclude sine theta is root 3 over 2 when theta is 60 degrees. Let's say we're asked to find another question, that is we're given cot theta equal to 1 and we're supposed to find out the theta in this case. Now we know cot theta is equal to adjacent over opposite because cot is the reciprocal of tan and tan is opposite over adjacent. So the number is 1. Since cot theta is adjacent over opposite, that means cot theta in this particular question is 1 over 1. So we're looking for adjacent one and opposite one, both sides to be 1. And we know both of these sides to be 1 is seen in this triangle. And for which angle is opposite also 1 and adjacent also 1? That's angle 45 degrees. Therefore, theta is equal to 45 degrees. And this is how we use special triangles to find out the angle if we're given the ratio. So we can be asked two types of questions. One is when we are given the ratios, we're supposed to find out the angle that we have just done here. And the other is when we are given the angles and we're supposed to find out the ratios that we did here.